right? So you have the successive forming of the sheet metal, as you can see. And instead of going for a direct this shape, we are progressively forming it. How? Using continuous dies, right? So they would roll, do their job, and then send it to another die, right? This is supposed to do its job based on the die orientation there, die and punch, and then the final one. So straight rolls, partial form, and the final form, right? Here you have the straight rolls, no what do you call profile being given, right? With the condition that straight profile is not a profile, right? That you have to bend to have some kind of profile. Then the second one is a partial form, it's not completely done. Third one is a final form, this is what we're looking for, and therefore then we can have it go outside and cut it into the required pieces. So that's roll forming. Spinning, right? This is another important topic. So you see, it's a metal forming process in which an axially symmetric part. So an axially symmetric part is gradually shaped over a rotating mandrel using a rounded tool or roller, right? So you can say it's a comprehensive way to say it. The spinning is a kind of metal forming process. With an axially symmetric part, right? Has to be axially symmetric. This is one condition here, right? This may come out as a disadvantage, right? If you look at it, but still, we have to have an axially symmetric part. That is the first condition. Now, that is with that part to be achieved, you have to have a gradual, what do you call, shaping, right? Just as we have done roll forming, right? Now we have to go for not just different die setups, but basically manipulating that shape that we want to achieve, right? Manipulating the shape on the sheet metal. Now, how do you do that? Over a rotating mandrel, it has to rest somewhere, right? And then using a rounded tool, right? The tool is what is more important in this process, because that is what is responsible for controlling the shape or profile, right? Shape or profile of the sheet metal, right? The three types that we have in spinning. You have the conventional spinning, you have the shear spinning, and you have the tube spinning. So you see, conventional spinning, you have a setup, right? And a sort of basically a mantle here and a clamp here, so that you can clamp this sheet metal to that clamp during spinning. So this is when it is being formed, right? Spinning. So this roller tool is what will apply force, and it will move here and there so that the sheet can take the shape of this die, because it is against, right? Like the force is applied against the die, and therefore it will be, that profile would be formed. So this is the end of the complete process. Right from here it started, and as it moved here to there based on the profile of the die, isn't it? That's what happened here. Then you can get this final shape. Right? This is conventional spinning. There are other types as well, and yes, this can be done uh, using hot working kind of method and then cold working. How do we define it here? Basically, hot spinning and cold spinning. So if you are working at temperatures above recrystallization temperatures, then you would call it hot spinning, right? And then Anything below that or above or in normal room temperature, then we can call it cold spinning, right? That is one way to differentiate. Now, and the cold working, as we said, right? The same kind of comments apply here. That is basically, it could be that the for example, in that hot working, we had seen strain hardening effect, right? That could also be present here because you're suddenly forming it. And right, so hot spinning and cold spinning, we can classify them, right, based on the reduced reaction temperature. Now you see, uses a spinning mandrel and a roller. Basically, now we are using a mandrel, right, and a roller, as we have seen, to form sheet metal into a radially symmetrical part, as we have seen. Axially symmetrical, radially symmetrical part is now being formed. TF, the thickness, very important. We want to have that constant throughout. And the roller tool, which supplies the force, right? Now you see how that component is, or the sheet is, what do you call, turned from this flat sheet into that shape you are seeing. You can see here, using that tool, so it gradually so that sheet is made to gradually take the shape, uh, basically the shape of the mantle, because the tool is pressing against the mantle, right? And therefore, this is how it will lead to forming of this shape. But as we have seen, it has to be actually symmetric or constrained, right? So that we can have what do you call, part. And also it does matter that how well that roller is interacting with the sheet, right? If it is, if there are differences, then the surface area is affected, right? So that is also another aspect. So the process is same as we had seen here, that the roller tool is moved so that this can shape, uh, it can take the shape, right? As for example, tube spinning, how do you go about reducing the cross section? I'm sorry, reducing the wall thickness. How do you do that? So we can use a roller that is inside the spinning mandrel, as we have, and a roller to reduce the wall thickness and increase the length of the tube, right? So you can see the movement of this tool is what is called feed, right? The speed at which it is moving. As for example, 2 mm per second or 3 mm per second. The speed of work actually depends on the speed of the roller, right? And how well it is interacting with the material. That is also another aspect. That is it able to form that shape, right? And so therefore, that is how you get those kind of components in tube spinning. We have hollow structures. Now another thing is, or let us have a look at this sheet. Sorry, spinning. Any doubts so far? Great, let us have. Right. Let us see what is hot spinning. Right, as I was talking about, we have two different terminology classifications being made. Either it is hot spinning or cold spinning, depends on the temperature. This is we had used, I mean, to our advantage, right? Uh, how is it able to? I mean, how we are able to better form the sheet when it is red hot, right? And lesser press or force requirements. But the problem is you would get the surface difference, so cold spinning and hot spinning, and basically moldability or formability is more when it comes to hot working kind of processes, right? Those are aligning with hot working. So therefore, you have this hot spinning medicine. So you see, it is being heated so that it can be taken to that state, right? That is why we call it hot spinning. And this is done using this gas welding or gas flames that are there, as we have discussed in in welding. So that is used. Those are used to increase the temperature of this sheet. You see how that is formed. We're melting it so that we can control the shape of that sheet, right? See, the side view is also shown. We're parting it off, right? Don't want the end portion. Therefore, we want to part it off. You see that smooth surface on that roller, right? That is kept in that sheet so that it doesn't affect the sheet metal much. right? Let's see this video. You will understand how that spinning is achieved with this roller. What is the importance of the movement of this roller? Now, machine is applying lubrication. Right? How is it able to form that shape? Because the workpiece is moving. You see, that is what the design intent was, to have that shape. So we had used cold spinning here technically, right? Cold metal, cold spinning to get that shape, right? Right. So as for as for high energy rate forming, right? This is one miscellaneous category we can call, but let us see this as well. That the processes to form metals using large amount of energy over a very short time. So within smaller amount of time, a lot of energy is being dissipated. How do we take that into account, right? That basically that is used to we call shape the sheet metal, right? Utilizing that technology as well, explosive technology. So basically, you have this HERF processes, high energy rate forming processes, as three: explosive forming, electrohydraulic forming, and electromagnetic forming, right? Explosive forming, you have some explosives which are used to impart energy to that sheet, and therefore it would what do you call it? It can be formed of different shapes. And electrohydraulic forming uses the principles of electronics, right? And even hydraulic here. So we are using some kind of fluid, right? That is helpful for us to form that. Electromagnetics, you use the principles of electromagnetics, right? So that we have seen to be able to achieve that shaping or forming of the course of the sheet metal. As for explosive forming, I told you, explosive charge is used to form the sheet. Basically, sheet metal into a die cavity. Explosive charge causes a shock wave, because we are seeing in a very short period of time, we have a lot of energy being generated. This way causes a shock wave, whose energy is transmitted to the forced part into the cavity, right? To force that part into the cavity, energy is utilized, explosive energy. Applications include large parts typical of aerospace industry. I will show you one video which are not included here, wherein they're using this explosive forming to achieve that spherical shape of a big ball. Right? This now made into what you call, how that is achieved, right? Is through explosive forming. You can see here this explosive charge is set so that this contacts and it gives energy through this fluid to this sheet that is kept here, right? Now that gas bubble forming is because of the shock, is because of this explosive being exploded, and therefore you get this shock wave, and it travels up and it travels down, right? As we know. So as it travels down, the sheet metal is basically acted upon by sudden loads, which tries to take that sheet to take the shape of the contour that is there. Therefore, you would have the final shape, and basically the gas bubble, right, upon explosion. So this is how explosive forming works. As for electromagnetic forming, we have told we form a mechanical force of the electromagnetic field, right? Mechanical force of the electromagnetic field induced in the work part by an energized coil. You're using a coil which is energized. So how do we induce that electromagnetic field so that we can take use of that? This is the most widely used HERF processes. Creation includes tubular parts. You see here. So that is how that coil is used to impart the shape. You can see here there is a recess, and therefore you will get this shape because of the electromagnetics, right? Right? Doubts? If there are any doubts, you can ask. Otherwise, we'll end the meeting. Okay, then. Thank you.